All right, in our last segment for today, we're going to look at the connections from page 387 in your textbook. This is the reaction of thymine with the leaving group with sulfite. You may be familiar with sulfites as a cause of migraine headaches. I happen to be a migraine sufferer, and one of the primary causes for me is sulfites. If we look at this reaction where the leaving group is replaced by sulfite in the product, you might be tempted to imagine that this is a simple SN2 reaction. But is it? And this is why it's important to go from a hypothetical proposal for a mechanism to an actual experiment where we determine the order of reaction. So if this were SN2, we could imagine, like in a typical benzylic position, the nucleophile attacks as the leaving group leaves. Now, if it's SN2, we would expect a rate equation where the rate for substitution would be proportional to thymine and to sulfite. And first order in both of those if it's a classical SN2 reaction. When the experiment is actually done, it was found that the dependence on sulfite was second order. Okay, so something else has to be going on here if this is going to be second order in the sulfite. So what's happening? Well, one possibility is illustrated in your textbook, again on page 387. There's more than one electrophile or electrophilic position in thymine. The first would be the direct displacement of the leaving group as we just imagined. But also we know that iminium ions are very electrophilic at the carbon. So as illustrated in your textbook, you could have the sulfite attack the iminium carbon, displacing the pi bond there to become a lone pair at nitrogen, and there's our first sulfite ion dependence. Now your textbook stops there with the arrow pushing and then invokes the lone pair from the external amine to come in then in a second step to displace the leaving group, producing now a new alpha-beta unsaturated iminium ion as depicted here. Here's the alpha-beta unsaturated iminium ion system. And so this system is now electrophilic at the beta carbon, which was the place of the leaving group a moment ago. A second sulfite molecule. All right, so the second sulfite molecule then attacks the electrophilic beta position here, producing another intermediate, pictured below. This intermediate then, the lone pair, can be imagined to swing down and displace the first sulfite molecule that came in, giving us a product that overall only has one sulfite in it, but this reaction would have a second order dependence, 1, 2, in sulfite, as the rate determining step here would most likely be the second sulfite. So all the steps before that would impact the kinetics that we would observe. And so we would then have a second order dependence on sulfite in these reactions.